Welcome to part 2 if I don't actually go ahead and like try to string these videos together like I should. So we were talking about for loops and lists and stuff, and we were doing stuff with all the crazy lists. No, stop. So if we go back, we can see the crazy list that we had. We're just printing out each element in it. That works totally fine, just like that. And I can't think of anything quite different from because right now it just says the collection type. So I'm trying to like do the basics of lists, but like I don't see what else you can do. Like so you can mix the elements. You can have basically as many elements as you want. Like I think you can say like let's say let's do a real quick experiment. While true, I'm gonna say x.append 5, and let's print x. I'm pretty sure this is like you can go forever. And actually I can print the length of x and you can see how many are in there. Well, look, already I have like, oh my goodness, that is 500 and up. It's about to hit a million elements right now. Wow, that is crazy. If I printed out x, it would take a while. So yeah, that's lists. And also like if you're dealing with a list, like say we did this while true x append thing. If you didn't have a list out here, like how are you going to append to something that doesn't exist, right? So sometimes you just want to make like an empty list, and that's just you put the brackets just like that. That's just like to, as you say, initialize this x before you do what you want to do. Because you can't just say like x, or like if you were in Java, you could be like list x or declare it or something. But no, you just set it equal to empty. There we go. And this is a list, by the way. I can print like the type of x, even though it has a length of 0, it's going to still do that. And if I say what's cool with this is there's nothing in here, I can say for I in x, print high. What is this going to do? Well, so I'm going to do another print statement down here. I'm going to say print done. So what is this going to do? Well, this is actually going to just print out done because there's nothing in x. So it's saying for each item in x. Well, we're done. There's no items in x. So we skip over this line. It's kind of like saying if false, right? Like it just skips over it. So that's kind of cool. Yeah, no, I guess that's a cool debugging thing. If you like your for loop just doesn't even seem to be like running, like it's probably because like your list is empty or something. So yeah. And then let's see. Oh, you know what? It's a really good debugging strategy is literally just print everything. Like that's because you could print out the x, print out that list there and see if it was empty. So yeah, now we're going to talk about tuples, I guess, a little bit. My guess is that these won't be that big a deal either. But a tuple is just like a list, except one annoying thing is that you can't change it at all. So if I say x.append 10, this is going to give me an error and say tuple object has no attribute append. So I can't do anything like that. I can watch this. This is annoying. I can index it totally fine. Get the first element. It's going to be 1. But if I try to reassign, like if I say x of 0 is now actually 9, it's not going to let me do that. It's going to say tuple object does not support item assignment. So basically, it's a what they call an immutable type. And actually, I'm going to check that to make sure. All right, here's a LinkedIn page telling you what the difference between mutable and immutable is. Basically, mutable means that you're allowed to change things in it like a list. You can add items to it and stuff. So a immutable type is like a string where you can iterate through it, you can like change this stuff, but the actual string in memory is not going to change. And one of these, a tuple, actually, it would look better from the Google page. You ever had that happen? Yes, tuple is going to be an immutable type along with an int, float, bool, string, and I don't know what Unicode is, but yeah. That means that whatever you can't change this in memory. I can totally say x equals a new tuple like this. Like that is totally fine. Like that doesn't give me any errors. It just changes what the tuple is. I'm just not allowed to go in and actually change this tuple. This tuple is locked down. It is done. And the same thing with a string. I can do pizza, and do like print x dot replace pizza. Is this actually a function? I'm going to be really embarrassed if it's not. Yeah, and it will change each pizza to high, but it's not actually going to change the x. Actually, yeah. So this is going to still be pizza, pizza, pizza. Yeah, and I just want to test. Same thing here. You can't like go in and index it and like set it equal to something. Or I guess make more sense to make it a string. But you can't like change the string because it says the string object is not import item assignment. And that's basically the idea of the immutable type. And you could totally redefine it. Like you can say x equals x plus x, and then print out what x is, and that's going to be totally fine. That's just concatenates it to itself. However, this x right here. After we have this x plus x, this is a new thing. Basically, it takes this string of memory and it concatenates it with another one that looks like this. Like we're going to do this, and then it will put them together. So then it looks like this now. But this is a totally different new string than this string. This string of memory is going to be completely different, unless your compiler does something weird, but I don't want to get into that. What are we on now? So we did string, and then, we talked about range. You can say x equals range of 10, and I can print that range, and that's going to look like that. And I can also, what else can you do? You can say iterate through it for I in range, or for I in x, print I. Same sort of deal. And remember, it goes 0 up to 9. And it looks like we're going to be talking more later about what the arguments do with like the start and end. So I won't get into that quite just yet. All right, the basics of the dict data type. Now, do we talk about dicts a little bit more later? Yeah, it looks like we talked about them there. But okay, dictionaries. I'm gonna draw this out like insane because I love dictionaries. Dictionaries are the funnest things ever in Python. They will change your life. All right. And if you hate dictionaries, my goal is to change your mind right now because they are the coolest thing you will ever see in your whole life. Okay, so how do we make? Remember we made that empty list. Well, how do we make an empty dictionary? Well, boom, just make it curly braces instead of x. So what's the difference between x and y right now? Well, y, if you print out the type of y, will be there'll be a list, and x is going to be a dictionary. So there you go. So you can define a dictionary like this, and there's a little like cool syntax thing you can do. Usually people put multiple, or you can think of it as being in line like this, where you say like 5 goes to 2, but most people like to like put extra lines so you can list them all out, and you just gotta remember to put commas in between each one. So basically, and yeah, this totally works. There's no errors, right? There we go. So basically, what is the point of having a dictionary? Well, let's say that, there's some instances where dictionary makes things easier, right? But there's sometimes like where like you totally need a dictionary. Although some people might tell me that's wrong. So let's just play with the dictionary and see like what it even is. So let's say that you wanted to store in memory a bunch of people's names and how old they were. So I'm going to say that Alice is 7, and then remember you got to put your commas. And I'm going to say that Bob is going to be 7 is, I'm going to put, Bob is 90, okay? And then Carl, I'm going to put, he's 780. He's pretty old. And then, what's the last guy? Who starts with D? Daryl is going to be 0.2. Does that make sense? And you don't put a comma on this last one, although I don't think it really matters. Yeah, you won't get an error if you do, but you don't have to. You can leave it off if you... Oh, that is not a... What is that? Okay. And then, yeah, that's totally fine. So now if I print out x, it's going to look just like this. It's going to say, okay, inside your dictionary here, you have Alice is 7, and Bob's 90, and Carl is 780, and Daryl is 0.2. So basically, a dictionary is some kind of mapping of keys to values. And what do I say by mapping? Well, a dictionary is actually a special, I'm going to get real technical stuff that I learned in my class, but it's a special, it is Python's version of what is called a hash map, which is super complicated. I won't get into that. But yeah, it's basically just I should have said that. It's a mapping of keys to their values. And so why is it useful? Now I have like this X, I can like, I don't know, like, I can print, what if I wanted to get how old Alice was? I guess I could like print the str representation of X like that, and then, I don't know, like slice this to like get like, up to 8 to like get like where Alice is. Oh, almost there. Well, I mean, I'm just trying this out. You guys know this. You can look things up in the dictionary. Okay, so we're going to look up like Alice, and this is going to say, 7, like that, because Alice is 7. So basically, what this is doing is it's saying, okay, so I like to look at it this way. You have a dictionary, and then this little indexing thing basically collapses it to be, looks up Alice in the dictionary and returns this. This expression returns 7, like that, and then that's why it prints out 7 like that. So this is cool. So let's get even further into this. So let's first of all, we don't have to make the types the same on both sides. So I can make this 80 is 7, and 4.2 is 90 years old. And this doesn't really make sense at this point, but that's totally fine. I'm going to print out X so you can see that. And you can make anything on the left side, any immutable type. I can make range 10 be that. I can make, what's another immutable type? Well, you can make a tuple, right? So I can say a tuple 1, 2, 3 is going to be that. And you can literally like go in here and say, okay, I want to look up what 1, 2, 3 is, and it will say that it is 0.2 because we mapped it to 0.2. And actually, you know what? I actually kind of hate this syntax. What I like to do usually when I make a dictionary, although this isn't the best way to do it, I guess, is I like to set it up how I'm going to use it, right? So I'm going to say x of 1, 2, 3, equals, let's say, my tuple thingy, and then I'm going to say my tuple, and then x of 3 equals 4, and then let's say x of range 100 equals 90, and then yeah, so that's totally fine. Same thing. It's going to print out, it's going to print out my tuple there. If I get rid of these brackets, so we'll go back to that original syntax we had, like those curly braces, and saying 1, 2, 3 is my tuple, 3 is 4, range is 90. Look, it converted my range 100 into range 000. It recognized that little shorthand there, which we'll get into. So what else was I going to say? Yeah, it's hard for me not to get excited when I talk about dictionaries. I just want to say so many things at once. So right now we've only been working with immutable types, but we can totally put mutable types like lists and other dictionaries over here. So I can say that range of 10 is this, and I can say that this is another dictionary where I can say like 7 is 9, and then hello is H or something. And yeah, so I can sort other dictionaries on the other side. Now if I print out X, the 1, 2, 3 maps to my tuple, 3 maps to a dictionary, range of 0 to 100 maps to a list. And then what's cool with this is I can go into X, say, okay, well, where is this thing? X, that's X of 3. And that's why I like the syntax, because I immediately know like where it is. You can even like copy and paste it right there. Bam. So X of 3 is going to be this dictionary, and then I can go inside that dictionary, and I can get what the 7 is, and this is going to be 9, right? Because 7 maps to 9 inside of there. And you can get like this dictionaryception thing. Like I can put another dictionary in here and say 8 goes to another dictionary where 9 goes to an empty dictionary. Or actually, I'm just going to say yay because we've finished our task. So how are we going to get this yay? Can you figure it out? How would I print out the yay there? All right, so let's give it a shot. So X of 3, and then I'm going to grab where 7 is right there, right? And then I'm going to grab 8, and then I'm going to grab 9, and this should print out yay. Almost there. I didn't put a comma right here. Got to remember that every time. Oh, wait, hold up. Something's wrong. You know what? I bet it's the brackets. Yeah, there we go. Give me a sec. You know what? Pause it. Yeah, sorry about that. I let the brackets get away from me. But yeah, so what is this doing? Well, print out yay, first of all. I got to do that. So what is this doing? Well, it's saying, go into X. Get me the third element. And from that, get me sorry, I said that totally wrong. Our dictionaries are not ordered, right? We don't have a third element. I want to go into dictionary X, get me what is mapped to 3. And then inside of whatever that is, because I somehow know that's a dictionary, I want you to get me what is mapped to 8. And inside of that, I want you to get me what's mapped to 9. And then that is going to be yay right there. So that's pretty cool. And so the reason I'm showing you this is there's one little case that you just gotta remember, and that is you're not allowed to put mutable types, like the ones you can change, like a list and a dictionary. I don't, are there even any more like, let's see, mutable types. Yeah, so list, sets, I don't think you've worked with sets, and dictionaries. So just remember, list, set, and dictionaries. I cannot use them as a key, okay? So if I say x of the list, let's make a list out here, actually. I'm going to say y equals list of 1, 2, 3. I'm going to say x of y is a string. And this is going to give me an error. It's going to say unhashable type list. And the reason that they did this is because if this worked, if I could go in here and say, okay, well, give me what x of, I want you to go into x and I want you to grab what maps to the list 1, 2, 3. And I think that would give me an error on that. Oh, sorry. What is going on? Okay. Yeah. So the reason this does not work is because if this did work, if this printed out my tuple, I guess it would be my list now. If this printed out my list, what would happen if we printed that out and then we said y.append 4 and then printed it out again? Like, well, y is changed now because we're allowed to change lists, right? So if we look up this 1, 2, 3, well, y is now 1, 2, 3, 4 because we appended to it. So that causes problems, right? Because now, what does it map to? Who knows? Maybe it's not in the dictionary anymore. So it's easier to say, you know what? Let's just not make the changeable types, the mutable types be keys. You're only allowed to use immutable types such as ints, floats, bools, strings, tuples. Basically anything but a list, set, or dict can be a key. And then a value can be pretty much anything you want, except maybe like, the keyword while. I just don't want to say anything because this doesn't make any sense, right? I don't know. So yeah. So what are we on now? So the last thing I want to say is sometimes, and I don't know if this is a technically correct CS thing here, but sometimes like when you're working with code, you'll really want to store a variable name, like say you have like a variable called 4 and you're going to say equals 4. Sometimes you'll really want to name this dynamically. Like you'll want to be able to change the name of your variable here. And actually, I want to say something. I wanted to relate back to the assignment, but I'm not going to do that. So sometimes you really want to like change the name of a variable, or say you want to name the variable 4, and then so say I don't know. This is kind of a bad example, but say like they're passing in like some kind of number, or you made some calculation off of. So you're saying y is equal to like 2 plus 2, something like that, and you want this to like map to or like have some value to it. It would be great if you could store a variable as 4, but it doesn't make sense, right? You can't name a variable 4 because that 4 is a number, right? So what's great is in dictionaries you can basically do that. Like 4 is like this value, and it stores it there. So I can say like x of y, and then this will print out 4. And if I want to add another one, say you have like different inputs or whatever, and it will map these numbers to these words or whatever you want, or another dictionary, whatever it is. Basically, it just made it. I don't know. I guess I just think of them as just like magical variables you could do basically whatever you want with. But I don't know. I always just freak out over dictionaries. I love dictionaries so much. All right, now reading files and websites. I used to use this website called ducksarethebest.com for this, but I don't think it is up anymore. I have to find a new website to play with. Hold up. All right, I just did way too much work on this, but my point with HTML code is, unfortunately, there used to be a website that had a duck in their HTML code, and I think the most important thing about learning URL lib request is getting a duck to print out on your screen. So this is our thing. I just had to do all the setup crap to get it online. But yeah, I have a URL that you can use to go ahead and get a duck on your screen. So what is this? And this is the next thing on our list here. Maintenance guy just came by telling me to, he's locking me. I'm in a weird classroom in Mech right now. It's nighttime. Okay, so it looks like the next thing on our list is, it looks like it is, the place that we are right now is reading files and websites. Actually, give me a sec. Yeah, so it looks like this is down here. So I guess I won't get into this yet. I just okay. I'll get to that at the end of the video, I guess. But this is coming up. I'm gonna print out a duck on the screen. Okay. So what about files? Reading files and websites. Well, I guess you know what. This is probably like the general stuff. But I guess I could. I'm just gonna wait. I need to wait until we get down to that. This is the end of the video. If you stick around, we'll get a duck to print out on your screen. It'll be wonderful. Okay. So reading files and websites. Are we talking about like opening and stuff? Yeah, it looks like we're going to be talking about open file name. Yeah, we'll talk about that in a bit. So I'm going to come back to that bullet. And then reading tabular data like a CSV, and that's another thing we're going to get to, like splitting on a something. So just give me a sec. Yeah, sorry about the delay as I try to figure out what this list is. So exam 2, is not cumulative specifically, but obviously you need to know how to print to do this exam. And then and also like definitely like I just said print and I feel bad. Definitely like returning to. Don't just print everything. Never mind. Sorry. And also asking about the tuple and test case selection debugging strategies. You probably don't need to worry about. I mean, you guys can read. I don't need to read this to you. So now we're at the specific list where we know how each thing is going to do. So let's go ahead and do that. This is the easier part of everything. All right. So I'm going to go fast through these. I'm going to try to go fast, not drag it out nearly as much as I did the while loop and for loop. But let's go ahead and do it. So the first thing we're talking about is random. So what does import do? First of all, well, importing is importing some kind of module / library. And what is that? Well, this means that some executive Python guys did some cool stuff and a bunch of extra functions that they put in like some file, and that file is on your computer somewhere, I believe. And yeah, because you can access it offline. So this basically what this import random thing is doing is saying, go get me that file that's stored on my computer that when I downloaded Python, it gave me all that cool random stuff. So yeah. So now if you look online, if you look at I'm gonna close all these tabs. If I go look at like the Python random library, I will show me like what's it'll show me like what methods I can do. I can do random.gets, and you won't have to know any of this stuff. But like rand range, I know some people use that. Rand int, shuffle's a good one to like shuffle up a list. I don't know, evaporate. What? No, I don't know. Expo variate. Okay. What the hell? Sorry. Okay. So that's basically just getting all these cool functions into your Python file. Just bring them right in here, and then you can use them just like if you imported like your higher-lower.py to go play with those functions in the higher-lower tester file, just like that. How you import those functions right into there. So now let's talk about these functions. So what is random.randRange low to high? And I always get this wrong whenever I explain it the first time, but I'll do my best. So import. We're going to import the random. All right, and then so what does this do? So random.randRange. Well, calling this function like this. Remember, you can't just do rand range unless you had it in your file, or you said, if you did like that syntax where you do from random import rand range. I'm pretty sure that that would allow you to just use it like that, but otherwise you gotta use this random dot first, right? So then we can use this function. And what this function is going to do is when you call it like this, it's going to return a random number between low and high. And actually, I can show you that. Let's see, rand range. So this is going to give us, it's going to return a random number that is in this list. And it says an even integer from 0 to 100. Well, what does that mean? Well, if it looks like if we pass in the first one, that's like where it starts. 101, it looks like it's going to go up to and not including that one. So see, because it says from 0 to 100, it's going to stop before you get to 101. And then this looks like it's going to say steps of 2 as you're going up. So let's try that out. So, okay, rand range, let's say 0 to 100. And so I'm trying to clearly make a mistake here and have you spot it before I do. Actually, I made 2 mistakes. I just put my random.rand range. So yeah, let's do that. And I'm testing your test 1 knowledge here. Let's see. Why doesn't this do anything? I got nothing. What happened? Well, remember, this is returning a value, so we have to print it out, because this is just like saying it's like saying 5 on a line, because this returned a value, but we didn't do anything with it, so we got to print it out. All right, so we're going to print out random.rand range. Okay, it's 15. All right, let me run it again. Oh, now it's 13. Oh, well, it's now 79. Oh, well. So it does all kinds of things, and let's see all kinds of things going to be while true. And sorry for the parentheses. You don't technically need those. There we go. And then I'm going to indent this line, and then print it out. And look at all these random numbers. Wow, none of them are above 100. See? Actually, none of them are even 100 because we specified that. If I go ahead and change this to a bigger number, we'll see that our numbers will get bigger, obviously. We stop that, and then here we go. Yeah, and now it's doing even bigger ones. That's fun. All right, so that is basically what random is, and so now what about random.shuffle? Okay, well, let's take a look. Random.shuffle, and it's going to shuffle the sequence X in its place. So what does that mean? Well, usually you're using this with like some kind of list or something. So, ooh, I just realized sorry, never mind. Something's going with my recording. Okay. So the random.shuffle, I usually think about this with lists. So if I have X equals 1, 2, 3, 4, 5. Actually, I just used this in 2150 the other day because we were testing our merge sorting program, and I wanted to test it on 10,000 elements, so I used Python to make them real quick. So Python is very, very useful, more useful than you think, I guess. So now what if I say random.shuffle, shuffle X, and then let's go ahead and print that out. And what happens? Well, I get none. And why do I get none? Well, remember, this kind of function is not one that returns one. It's one that's actually going to go into the real actual X and do something, change the actual original one. So yeah, you just put random.shuffle X that says go actually take this real X, scramble it up. Then I'm going to print out X, and then it's going to be scrambled. And I can do it multiple times, and it'll be scrambled every time. Actually, yeah. And then, yes, that's pretty much it. Just remember that this one, random.shuffle, is going to return, it's not going to return anything. If you print it out, it's going to give you none. It's still going to do it. Like I could print this out, it'll do none, and then print my list shuffled. Like, it still does it. It's just like, okay, well, I did it, and you also want me to print my return value, but I don't return anything, so I'm just going to do none. So there we go. And then this one's going to return the number that's between low and up to, and not including the second value in there, because yeah, it looks like where is it, range, yeah, because this went up to 101 and we were just doing 0 to 100. So just like in range, we go up to and not including that second argument. So it's gonna go, yeah, okay. What if I do rand range with just one number, I wonder? Well, let's try that. Print random dot rand range 10. Let's see if this works. I bet it doesn't. Oh, it does. I guess that goes from 0 up to 10, right? Yeah, it looks like that's what it's doing. Yeah, so we got a 0 right there. So yeah, I guess we can use it the same way. It might just be better to just go ahead and put the 0 in there just to be safe, you know. And remember, this isn't going to include 10 because, yeah, okay, I dragged things out way too long. I'm so sorry. All right, so now we're looking at str, which is what? It's a string, right? And typically, you don't want to name your variables like str equals hello. Like, this will work totally fine. I could say, like, you know, print str, and then this will work. Yeah, I'll say print hello. But then what happens if I later have z equal to 6, and then I say, oh, well, actually, I want to print my value is, and then like plus z, and then I go, uh-oh, because it doesn't, I can't concatenate. It's like, okay, well, now I'm going to do str of z, and then, yeah, and then let's see what that happens. Uh-oh, well, this is now broken because str is no longer this built-in Python function that changes things to strings. This str is now been redefined to hello, and now you can no longer use it in the file. So that's kind of like just like the reason you wouldn't say int equals hello or print equals hello. And this is a fun one because if I say print equals hello and then I try to print it can't do it because this is the same thing as, you know, saying hello. like hello and then like whatever value you're putting in here. It doesn't make sense, right? Because you can't call a string. It's not a function. So sorry, tangent there. So yeah, we're talking about str, this type. Yeah, so we have substring in string. Substring is basically a portion of a string. So a substring of the word string would be like stree, right? That's a substring of string. Also a substring, I guess, technically would be the whole thing of string. And what this syntax does here, I guess it does two things really. If you can think of if this is wrong, let me know. But so the first thing is this can return true or false. So I can say like x equals 3 in 1, 2, 3, 4, 5, and then print x. This is going to be true, right? We got true right there. I feel like I should blow this up. Well, then you can't see the extended output thing. I have to leave it like that. There we go, true. And then, but if we get rid of this 3, we get rid of that 3, that's going to say false. What if there's multiple 3s? Totally fine, right? Still there's 3 and 3, right? Now we have true, totally fine. And then what if we do the whole thing in the whole thing? What if I do that like that? Whole thing and whole thing? Well, it's true, because is this in this? Well, yeah, it is. The whole thing's in the whole thing. So that works. And then you've also seen the in operator when you're using a for loop. We say like for I in x. Well, x is a Boolean. We can't go through that, right? So 1, 2, 3, 4, 5. For I in x, print I. So this is kind of interesting. So this is normally you can use this to like return true. Like you can say like if you can say like if 1 in x print I have found 1. So this is going to say I have found 1 and also print out every element in it, right? If we get rid of this, obviously it won't print that. Yeah, it's kind of interesting how you can use it in both cases. I wonder if like technically this is some kind of like while condition or something, but I don't want to think about that or say anything wrong. So I'm just gonna that's some food for thought, I guess. Now we have string 1 plus string 2. Oh, come on, we did this in test 1. So all right, so let's say x equals you have 1, 2, 3, and y equals 4, 5, 6. And if I want to print 1, 2, 3, 4, 5, 6, what can I do? I can do print x plus y, right? Here we go. 1, 2, 3, 4, 5, 6. And just the one thing I'm remembering to say to don't forget with this. Well, first of all, if y is, well, first of all, if these are both numbers, 1, 2, 3, 4, 6, this is not going to print 1, 2, 3, 4, 5, 6. This is going to print the sum of them, right? 5, 7, 9. So you have to be careful with that. If you make one of them a string, you can't do a string plus a number, right? Doesn't make sense. So now you have to, you would have to cast this one to a string like that, and then it would work. And also, some people use commas to separate them by spaces here. And the important thing to remember is that you can't use commas out here and say, okay, I want you to do 4, 5, 6. That will not work because that will create a tuple. And this program still works totally fine. Basically, it says x is a tuple of 1, 2, 3, and 4, 5, 6, and then y is the number 4, 5, 6, and this printed about with a comma in between them, or space in between them, and then it did that. And actually, I think when there's a comma, you don't even have to do the str if it's a number, because it will just print it out just like that. Because remember, you don't have to print, you don't have to put it into a string every time you print when it's an argument on its own. It's just when you're concatenating it to another thing, when you're doing the plus number. So, what is next? So we have string.lower. Okay, and I know I posted on Piazza about this one, but all right. So this one's pretty simple. If I say a bunch of stuff with upper, and actually let's say, yeah, maybe do you remember that thing with like SpongeBob where he would like say hello, like there or something? It's supposed to be like mocking, like hello there. I don't know. So if we print x, it's going to print like that. Let's say I guess someone like hacked into our system and like changed all the case things, and it's annoying, and it's now like this. And a good way to just like fix that, you can do x.lower like that, and then it's going to put it all lowercase and get rid of all the uppercases. Another thing is upper, and that's going to put them all in uppercase. And a good thing to do is like if like x is like the input of something and they put in some value, and then you're like, if x equals like do thing 1, a lot of times you want to do like this. You want to take this and do x dot lower, because that way you say like, okay, well, you know what? I don't care what the case is. I just want to get like what they typed. So that would like make it so if they typed like do thing 1 in there, then they wouldn't mess it up. An important thing to remember is this returns something. So if I do x dot lower like this doesn't change x. Actually, I'm gonna put this back. Grab this right here. Put this back there. I have to put it in quotes. Sorry. There we go. So if I do x dot lower and then I look at x again, this doesn't actually change x. It's still upper and lowercase. But if I don't print it after, this won't do anything, right? I got to print this out because this is returning value, which I'm driven home a million times. But yeah, there we go. Why is there a slash there? That is weird. Oh, because I typed a slash when I don't know. Okay. So we did lower and we did upper. All right, strip. Strip is very fun. Strip is when you're getting rid of any kind of white space. And this is another one that's going to return, so it won't actually change it. We'll just make a copy of x and do the stripped version. So if I say like x is high, but oh crap, my battery's low. Hold up. I ran my whole battery down for you people. All right, so this is like if you're putting out high, but there's a bunch of spaces on it. Usually when you're getting some from online, you'll have these annoying spaces. Sometimes you'll have new line characters in here, like new line, and like maybe some tabs in here somewhere, and like some spaces. And this is basically just going to, well, if I print out x, first of all, let's print x when it's not stripped, and then let's print x stripped. And I'm going to print it out one more time, or I'll do that in a second. But all right, so I'm going to print a divider so you can see the difference. Print. Yeah, so the first high is way out here. See, like we did all these tabs, and then we did 2 new lines after it. And I can actually like put another new line in here, and then if you see that, this will be like high, but it'll be down. It's like way, all this white space. This makes it really annoying to check when you're like saying like, does this equal this? Well, it's like in the middle of all this like space. So what you can do is you can strip it. And that just basically says, okay, well, I'm just going to go bloop and get rid of all that, and then bloop and get rid of all that. And basically, yeah, it just gets rid of all the white space. And you see that after here, it's just everything that isn't white space in the middle. Now, an important thing to remember is if I have like high there, and I have like some white space in the middle, that totally does work, right? Because it's only going to remove the white space from the outside. So once it's going to start basically from the left and go, okay, white space, white space, white space, white space, stop. And then it's going to go to the right, white space, stop. And then this is going to be a resulting thing, so that's going to be, that's why the space is still in there. So yeah, that's strip. And then splits, for some reason people get these mixed up sometimes, but they're very, very different things. So let's say that we have x equals 1. Oh, I forgot one thing. So strip is going to strip on the white space automatically. Just like that. If you don't put anything in there, it's going to strip on that. Say we only want to strip on the space. We could strip on that. And it would actually, yeah, because it didn't remove the tab. See, it's still way out here. It just removed some of these spaces in here. It's hard to see. But yeah, let's say instead of having white space, we had a million T's. Like somewhat, like for some reason we just have so many T's, and it's really annoying. And here we go, there's more T's. It doesn't matter how many T's we have. I'm going to say, okay, strip all the T's. So it's going to strip all those T's out. And see, the first one had high there. And the second one, I'm going to get rid of these tabs in the middle. The first one had the T's in there, and the second one got rid of them. So basically, strip is saying take from the outside all the things. And what if I had like pizza, 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 peas. I'm going to not say the last day. And then I'm going to say P, and then pizza, 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 and then pizza. And then I'm going to say strip the pizza. Get rid of the pizza. What is this going to print? What do you think? Can you see the whole thing? Maybe if I move this over, can you see? Can you see it? What is this going to print out? Ready? And I tricked you a little bit. So I didn't type pizza fully on one of them. So let's print it out. All right, yes, so see, wait, hold up, what? Oh, okay, I totally forgot. So I was thinking that it's going to go in here and say, okay, this is the pizza, get rid of it, this is the pizza, get rid of it, this is the pizza, get rid of it, oh, and then that's not a pizza, and then leave it in. But actually, remember that when we do strip, it's going to say strip any of these characters in any order, combination, anything. So actually, if I say strip, if I say pizza, I only need one Z, right? Pizza and then a H. That's going to get rid of that first H on that high. So it's just going to get rid of everything that, well, actually it got rid of the I too because I is in there too. Yeah, so basically, I'm going to show this one more time just to be 100% clear. Let's say that XXX is what we're trying to print out. And then on either side, I'm going to type a bunch of stuff with, I'm going to do my QWERTY on my thing here. I'm just going to do random stuff with that. And we can actually mine out that XXX with just saying QWERTY, get rid of all that stuff. And then, bam, that one has a bunch of stuff in it. And then that's just the bare bones. All right.